In training that I've done with customers and with business partners and end users, there is often some confusion about VBC alarms and why they're so different and why they are quite complicated. And they are. There's no getting around that. VBC alarms are quite complicated. So I hope to demystify some of that this afternoon. So I'm just going to share my screen and take you. I've got a presentation with some slides and some key moments in. You'll be able to see these again on the recording, of course. And also I'm going to take you to the VBC. There's much less on the VBC this week because this is a bit of a theoretical subject, and it also won't be very long either. We'll be about half an hour, 40 minutes maximum. So I'm going to share my screen, which I've now currently done. So I'm going to log in to my VBC, which is the VBC demo system in Oslo. And of course, everyone has got access to the VBC. You can just use that URL there, vbc.bridgetech.tv, and log in with user credentials, username demo, password demo. And you can get in and see everything that I'm doing. Well, no, you won't be able to see everything I'm doing because you will only have read access. So you can't write. But the first thing I want to show you is whenever you're installing a VBC or whenever you're talking to an end user customer about VBCs, then if you go to the alarm setup, ignore the top page for the moment, we'll come back to that later. But I just want to show you these 3 links down here. And these links are links to 3 manuals. One of them is quite long, but the other ones are fairly short. So understanding probe alarms just brings me to a PDF that you can download and keep. And it tells you about probe alarms, and it talks to you about how round robin works and how alarm thresholds work. It's a general manual, but it is very, very useful. So that's the first manual. The second manual is VBC Alarms, and we're going to be talking about VBC Alarms today. Everything I'm going to show you and everything I'm going to tell you and you see on the slides all comes from this manual, pretty much. It's, as I said, it's slightly complicated. People say, oh, why are VBC alarms different? And why do they need to be different to probe alarms? And so I've put forward this training segment for to demystify some of these problems. And we've got details of VBC alarms here. So these are the 3 manuals. Now, they are quite old. They've been around for a long while, but the VBC alarm model hasn't changed in all that time. So when we look at VBC alarms, the model hasn't changed. There are some things like some new alarms are featured in VBC, and we'll see some of those later. But the actual way that the VBC calculates alarms hasn't changed. The reason that VBC alarms are as complicated is because they are, like the probes themselves, very versatile. In the default mode, the VBC will be fairly responsive to probe alarms. You can change the settings to make it very, very responsive. In other words, it responds immediately to all alarms or most alarms. You can make the VBC very sensitive to probe alarms, or you can make it less sensitive. The default position is somewhere in the middle. Of course, if the VBC is very sensitive to probe alarms, then you get a lot of alarms. Alarm logs start filling up and you get a lot of data, much of which is not really very useful. So Bridgetech have modelled the default VBC behaviour on a series of experiments that gave the best overall coverage. So let's look and see how this works. So I'm going to switch now to a presentation. So now explaining VBC alarms. So the VBC needs to collect alarms from multiple probes. some of our systems are in excess of 100 probes, and having one probe alarming can be distracting enough. Imagine having 100 probes all reporting back to a single VBC that CNN International has disappeared across the entire network. Very soon it would become unmanageable. So the VBC has to aggregate alarms. It has to aggregate alarms across multiple probes. And it takes account of, if, for example, I've just mentioned CNN International. If CNN International disappears from your downlink site, so in other words, you're downlinking it via satellite or something, and it disappears there, it might then disappear coming out of an IRD. It may disappear then going into an encoder or or some sort of rate changer. Then it would disappear coming out of the MUX, and then it would disappear in the distribution network and in regional head ends, for example. So it would be quite possible to have dozens of alarms all saying that CNN International has disappeared. All the different probes in the sequence will report it as being missing, and that's not very useful. It would be far more useful if the VBC said CNN has disappeared, and if you as an engineer need to drill down and find out where has CNN disappeared, then you can do that. You can click with one or two clicks, you can find, oh my goodness, it's disappeared everywhere. But mainly it's disappeared on ingress. So this is how the VBC works. Alarming is based on error seconds. And error seconds, I'll explain that a bit later there. If you've read on ahead, it's there. Error seconds, not individual alarms. So an alarm may occur once, or it may occur 5 times. So we don't get 5 different alarms. If those alarms occur in a single second, then we get 1 error second. So normally a VBC will poll a probe about once every minute. Every probe in a network will be polled, and the XML document is sent back to the VBC, and the VBC then processes that for every probe in a network, in a monitoring system. And then it does the calculations to see whether the probe alarms are going to cause a VBC alarm. So an error second, they're calculated by probes, and they check whether an alarm has occurred in a 1 second window. So basically, when a probe is looking at alarms, it bases everything on a 1 second interval. 1 second, the next second, the next second, and so on. And then it counts, yes it does, it counts the number of errors in that second. So if we're looking at, say, a PCR error in an ETR priority 2, and we've got a PCR error, then the probe will say how many priority 2 errors that are PCR have I had in that 1 second. And it doesn't matter whether the probe has had 1 error in that second or 25 errors in that second. It still registers a single error second. So it's not about the number of errors, but it's the number of seconds that actually contain errors. And that's what the probe uses and the VBC use to detect. So when you look at the VBC thresholds in a probe, which we'll look at later, you'll see that the numbers are about error seconds. And that determines whether the VBC will raise an alarm. So it's error seconds, not individual errors. It's really important to remember that. So media loss rate, for example, packet loss, it's really important to know about packet loss. So you'll always get an error second. It doesn't matter what the thresholds are set to. If you lose a UDP packet or you lose an RTP packet, then you will always get at least 1 error second. Doesn't matter what the thresholds are set to. However, other measurements like inter-arrival time, IP jitter, will result in error seconds, but only if it crosses the threshold. And that is a user-defined parameter. Users can define their own error thresholds. And that's part of this story. So this tells you how sensitive the probe is by changing the thresholds. So when we look at error seconds for media loss rate, and these could be, remember, RTP drops or UDP drops and other parameters, not just these, but these parameters are the ones that I'm using for illustrative processes. So error seconds, because they are independent of the threshold, you can compare these across different probes. So one error second in probe A and 1 error second in probe D will be exactly the same. However, if we are looking at inter-arrival time, IP jitter, remember these are dependent on the thresholds. So comparing an error second on probe A for inter-arrival time and then on probe D for inter-arrival time, they're not necessarily comparable because the probes individually have their own thresholds. Error seconds, ETR error seconds, are only used by the VBC to generate ETR alarms. You can't see them anywhere. You can't go into a probe and say how many priority 2 ETR 290 priority 2 error seconds you've got, because they only exist in this mechanism for counting and only in the VBC. Now remember that if you are looking at ETR 290, of course, ETR 290 monitoring occurs in 2 different ways. It can occur 24/7 if you dedicate a single ETR engine to a multicast stream, or indeed if you are receiving a transport stream from something like a satellite receiver, then you will be monitoring 24/7, assuming that the satellite receiver is not doing round robin as well. But nevertheless, so that would give you continuously monitored stream, and these alarms will stay active for at least the duration of the ETR 290 threshold. And the timeout settings, we'll look at the timeout settings in a minute. So when you monitor and you raise an alarm, then the monitored parameter must be clear of errors for the error timeout period. So if an error disappears, and again we'll see this in a minute, if an error disappears, it isn't immediately cleared on the VBC. That error has to have disappeared for a certain amount of time before the VBC then clears that alarm. This is to make sure that alarms are not continuously going up and down. If you're getting alarms on a probe that appear, disappear, appear, disappear, then the VBC doesn't clear them until this period of the error timeout is cleared. And this makes sure that the alarms don't keep going up and down in the VBC. When you're doing round robin, if you've got 2 multicast streams sharing an ETR engine, then of course they'll spend 50% of the time being monitored and 50% of the time not being monitored. And if you've got 4 multicast streams sharing an ETR engine, then it's 25% monitored, 75% not being monitored. This is how round robin works. And when the VBC makes these calculations and it sees that the probe is spending 25% being monitored, the stream is spending 25% monitored and 75% not being monitored, then it takes this into account when it does the calculations for the number of error seconds and the amount of errors when it generates a report, for example. So the VBC has this intelligence to know when a stream is being monitored and when it's not being monitored. Thresholds are used to generate VBC alarms. They're in the probe. They're actually in the probe itself. So every probe can respond to the VBC differently. It can report to the VBC differently. So probes are not all the same. And what this does is this gives the flexibility to allow probes in different parts of the network to respond differently. So the VBC threshold's in the probe. So this is in the actual probe. It's the VBC threshold in setup. You can see that the parameters allow specific response characteristics for each probe, and each probe unless you change these, each probe will be the same because they use the default threshold. And remember from previous training sessions that we've done and your own experience, you cannot change the default thresholds. Doesn't matter whether it's ETR 290, OTT, you must duplicate the default threshold and rename it, and then you can change it. Each entry specifies the threshold, the number of error seconds that need to occur before a VBC alarm is raised. So no signal, it's 0. So in other words, 0 errors. If it goes no signal, then immediately raise the alarm. RTP drops, immediately raise the alarm. So when we look at ETR priority 1, priority 2 and priority 3 alarms, then you can see that we need 250 error seconds. So the probe will not raise an alarm to the VBC until 250 error seconds have occurred. Notice that the ETR, earlier I made a mistake and I said ETR priority 2, PCR error. In fact, it doesn't matter whether it's a PCR error or a PTS error. They're both priority 2 errors. And each of those will combine and total up to 250. And once 250 is reached, then the probe will signal to the VBC, yes, I've had 250 error seconds. And you can see for OTT it's set lower at 60 error seconds. And what happens is, if you read the text underneath, the VBC has an alarm window of 60 minutes. Again, we'll look at this in more detail. I've got a little animation that shows you how this works. So the probe is saying, I'm not going to report anything for 250 error seconds. And then the VBC is saying, I've got an alarm window of 60 minutes, in other words, 1 hour. So it's looking for those 250 error seconds in a 1 hour period. So this is 2 different measurements that are being carried out. One by the VBC in the hour and one by the probe for the error seconds. So 250 or more error seconds in a 1 hour window will cause the VBC to raise an ETR priority 1 or priority 2 alarm. So you can change this. So if you decrease that number from 250 to say 100, then this probe, remember this is on a probe, this probe will become more sensitive and it will say, it will then tell the VBC to raise an error if it sees 100 error seconds. Whereas another probe somewhere else in the system will only raise an alarm when 250 error seconds. So this is the way that you make the probes more or less sensitive. And then in the VBC itself, then we go to the VBC and then we set this window. Remember the default is 1 hour. So we set the interval with the probe error seconds counted. Those 250 error seconds, they've got to occur in a 60-minute period. Any fewer than 250 in a 60-minute period, and the alarm isn't raised. A VBC alarm isn't raised. You can web browse to the probe and you will see these alarms, but you won't see them in the VBC unless they exceed this threshold of 250 error seconds in 1 hour. Now I can change that. I can change that to 30 minutes. So 250 in 30 minutes is actually going to make it less sensitive. Because whereas before we said, right, we need 250 error seconds in an hour, we're now saying, no, we need it in half an hour. So that actually makes the VBC less sensitive. And the other thing you have to remember is this is the VBC threshold. It's not really a threshold, it's alarm setup. But, and this applies globally, of course. So whereas we can adjust the probes individually with that particular threshold there, we can change the probe sensitivity. When we go to the VBC, this is global. So the entire system now responds to that 30-minute window that I've just changed. And to the right of the 30-minute window, you can see a number 5. This is the reset window. So when the VBC raises an alarm and says, yep, I've got an ETR priority 1 error, then the the VBC will not clear that alarm for 5 minutes after they disappear. So the window, you're setting the sensitivity, and with the reset window, you're setting how quickly or how slowly the VBC alarm clears. Remember, there's no mechanism for clearing alarms manually. An operator or a technician or an engineer cannot go into a VBC and click clear alarm. That won't happen. Some systems allow you to do that, but Bridgetech doesn't. Bridgetech, the only way of clearing an alarm is by the alarm condition disappearing. Okay, so let's have a look at this in a little bit of detail. So we've got a VBC alarm window of 60 minutes. So we've got 0 on the right and 60 on the left. And we've got a stream, and that stream is all green because there are no errors and no error seconds, remember. Error seconds, not individual errors, but error seconds. We have some errors coming along. So we've got 250 error seconds because the probe has said, oh, I've got 250 error seconds, but they haven't all arrived. They haven't arrived in the 60-minute window yet. They are, so the VBC is only seeing, say, 175 at the moment. Time 0, 175 error seconds have been logged by the probe and the VBC. Now, obviously, 0 minus, that hasn't actually happened yet, but we are assuming it's going to happen. We've got 250 error seconds have now occurred. The probe and the VBC have both counted 250 and they're inside the alarm window. So now we have a VBC error. The VBC is saying, yes, we've had an error now. Now what you're thinking is, well, hold on, we've had loads of errors and the VBC hasn't reported anything. It's only reported them after we've had 250 error seconds. And if those were continuous, what's 250 error seconds? A few minutes. So it won't appear on the VBC for a couple of minutes, a few minutes in fact. So that's something that you need to bear in mind. Errors will happen on probes and you may not see them on the VBC for some while, at least a couple of minutes. So that's one of the calculations, one of the calculations that you need to do when you're helping customers to set up their VBC systems. This has to be borne in mind. So what happens next? So now 5 minutes has gone and no errors have occurred. So we've still got that 250 error seconds. They're still in the 60-minute alarm window, but now we've had 5 minutes without an error. So this is when the VBC error clears, and only after that 5 minutes has occurred, the VBC alarm clears. So not only is the VBC not reacting instantaneously to the errors appearing, it doesn't react instantaneously to the errors disappearing either. So again, that's something you need to bear in mind. You can change it if you want, of course you can. You can set the error window, the reset window, to 1 minute instead of 5, and you could do that if you wanted to, absolutely no problem at all. So now, further on down the hour, we see that we've got the first 250 errors are almost out. So we've gone nearly an hour now. We've gone, I don't know, about 55 minutes. We've gone about 45 minutes, 50 minutes, and there have been no errors. But we know there are going to be some errors coming. So that probe, that same probe, remember, in that stream, that same stream is going to report some errors in a minute because they're about to happen. They haven't happened yet because we can't go backwards in time. So they haven't happened yet, but they're about to happen. So now, as you can see, the errors on the left have almost exited the 60-minute alarm window. But now we've had 150, nearly 200 errors appear in the alarm window at the left. In other words, just now. So in total, looking at the alarm window, the VBC can see more than 250 error seconds. But we've had a huge clear period in the middle. So straight away, the VBC will raise another error. So the errors are not, well, they probably are connected because they will be the same. They will ETR priority 1, so they might be the same errors. They might not. It doesn't matter. The VBC will raise an alarm, and then a couple of clicks you can interrogate what the alarms actually were. But right now it's generated an alarm and it's popped up on the alarm window on the main screen, status screen. So you have to, the VBC has got this alarm window which is constantly monitoring all of the alarms coming in from the probes. Why all this complexity? It is complex, and I've given you a flavour of how complicated it can be. Well, it allows the user complete control. Not only does it allow the entire monitoring system to be fine-tuned, it allows individual probes to be fine-tuned. You can alarm on a single event if you want. Absolutely, you can do it. You need to set the probe VBC thresholds and the VBC Alarm Setup to do that. All of this information, remember I said right at the very beginning, I brought all of this information out of those manuals. So a long alarm window and a short reset time will give you the minimum number of alarms. The minimum alarm windows and the reset time will give you near instantaneous alarms. Again, it's one way or the other. The VBC defaults and the probe defaults are in the middle. So when you're tuning alarms, if you're helping one of your customers, end users, or you are an end user, feel free to play around with it. They're very useful tools. Always start with the default settings because I calculated these as being the best general settings for a VBC and a probe. They are a very good starting point. Take a manual VBC snapshot, and if you haven't seen snapshots, I'll show you them in a minute. Take a snapshot, download the probe configuration file as well, and this will enable you, if you mess up things completely, you can reload the VBC snapshot, you can reload the probe config file, and you get back to exactly where you were before you started. And that just goes for any maintenance work on a VBC or a probe. Always take a backup of the configuration file or a snapshot. Change one parameter at a time. If you're doing a scientific experiment, you only change one variable at a time, because if you change more than one variable, you don't know which one's made the difference. So only change one parameter at a time. Remember to change the probe VBC threshold. So you've got to do both. You've got to change the probe VBC threshold and you've got to change the VBC alarm setup. And the VBC alarms affect all probes. Whenever you make a change, then wait. Watch the effect over a day or so, certainly a few hours. Remember, the alarm window's an hour in default, so you can't expect to see anything in under an hour. So wait, just observe how your changes have affected the VBC and probes. Have you got too many alarms or have you got too few alarms? So back off those changes you made by a little bit or increase them a little bit. Check again. It's an iterative process and you do need to do it. It's like all things. You've got to go through a little bit at a time, see what changes. There's no magic formula. You can't ask me what is the best setting for, well, I can tell you the best setting. The best setting is the default setting, but it may not be appropriate for your customer's needs. Your customer may need to see more alarms and more quickly. So that's where you change it. So that's the end of the presentation. Let's get back to the VBC very quickly. And so we saw the manuals there in those links, and they're in every VBC. So we talked about if you've got 5.5 or 5.6 VBC, then you've got these snapshots, and I can take a manual snapshot. So I can actually make a snapshot of the VBC now, and I can add a manual snapshot, and that would take a snapshot of the VBC processes now. And if I need to go back because I've changed something, I've mucked something up, I've forgotten what I did exactly, then just go back. Reload one of those, the snapshot that you took, reload it, and VBC is returned to normal. So do that for the VBC, and then go to the alarm setups, and this is where you change the windows. So the windows, you can change that any way you want. You can type it in, 25, 30, and you can do so on and so forth. You can't change some of the reset windows down here. For things like extractors, you cannot change the windows. They are set in stone as far as the VBC is concerned. So a single minute as the window and a single minute for a reset as well. You may have noticed some new alarms down here. This is coming with 5.6, QoE video alarms, QoE audio alarms, and stuff like that, caption quality and things like that. This is new in 5.6. You won't see that in 5.5 at the moment. So then when we go to the probe itself, so let's look at a probe. Let's just pick a 120 at random. Remember the VBC alarms down here. The VBC alarms, they've all been cleared because this is how the VBC sees it with all of the alarm windows. And we go to setup and we go to VBC threshold. Then you can see we've got some default thresholds. I think there are 4, I'm not sure. Some of those have been added. So if we look at the default threshold, these were what we saw in the slideshow earlier. And again, if I want to make my actually 500, not 250 at all. So with 5.6 we seem to have increased this to 500. If I wanted my RTP drops, I could change that to 1. And that would make every single RTP drop a VBC event. So again, change them, play around with them. And remember, of course, I did say go to download the full configuration and back it up before you make any changes. Well, that's the end of this session 12 on VBC alarms. I do hope you found it useful. And thank you for watching.